Good evening, students. How are you? I hope you are fine. Again, is there extra class of maths today? Only two of you have joined. Where are the others? Hello? Is someone else joining? Okay, fine. No problem. So, how was your day? I hope it was good. Right? Okay. So, what are we gonna do today? Yesterday, we were discussing continuity. So we discussed this question last time. I hope it is clear. We have seen what are continuous functions. How does continuity helps us in determining the nature of the function? Okay. So now today, let's start with a question. So if you remember, we had done a question in limit. The last question. This is something like that. You should remember. So, what is the question saying? The question is saying discuss the continuity at x equals to 0. Means we have to discuss at x equals to 0. Again, if you remember yesterday's class, if they have not given x equals to 0, then 2 will check at x equal to 0 because at x equal to 0, the definition of the function is changing. But since they are very nice for us to give, that they have given x equals to 0. So let's start the question. We have to evaluate three things. The functional value at x equals to 0, which we can clearly see is 0 from here. Then the limiting value, and the function will be continuous if both the values are same. So let's find the limiting value. So limit, my audio is all right, or is it some problem in audio? Hello? I think I have a good connection here. I don't know what's the problem then. Hello? Now it's fine? It's fine now, right? Okay, fine. Chalo. So limit x tends to 0. What is limit x tends to 0? X tends to 0 means x is not equals to 0. Means which definition will use? The first one, x square into sine 1 upon x. If you remember this question from limit, we have done this is not an indeterminate form. Why? Because if we put x equals to 0 here, we'll get sine of some infinity. But we as all know that the value of sine is always between -1 to 1. The value of sine is always between -1 to 1. Again, some audio problem. Now it's fine. Is anyone else except him having an audio problem? I think it's your audio is again bad. I don't know what's the problem. Please confirm if anyone else is having the same problem. If not, then I think your network is bad, but let's see. Someone else having the same problem or not? Hello. Okay. Yes. Okay. Let's see. Let's wait some time. Or should I The audio is cutting or you are not able to hear. I'll turn off the camera for some time and let's check now. Okay. Cutting. Okay. Okay. I'll turn off the camera for some time. Let's check now. How is the audio coming? Now it's proper? Okay, hello, hello, hello. Now the audio I should think it's should be proper. Yes. Okay, let's try this way. After some time I'll on my video. So as we were here, as we know the sign value is between -1 to 1. That means what case we have here? Here we have the case that if we substitute x equals to 0, then I will get 0 into a value between -1 to 1. A value between -1 to 1. So that means 0 into any value between -1 to 1 is equals to 0. So that means my limiting value and the functional value both are same. And if the limiting value and the functional value are same, that means the function is continuous. I hope you remember it. This type of question in limits we had done last sum of limits we have done implies function is continuous at x equals to 0. Chalo. Now, if this is clear, let's move on to the next part. Next part means next question. Now only questions are left. This one. This is another type of question which they can ask saying that the function is continuous, then find some value of constant. So here they are saying find k if function is continuous at x equals to 0. So here continuous. That means the functional value at x equal to 0 is equal to the limiting value at x equals to 0. So x e raised to x plus 10x upon sine 3x. So let's check the indeterminate form here. X0. So we'll get 0 plus 0. Tan 0 is 0, sine 0 is 0. Means the indeterminate form is 0 upon 0. That means I can use LH rule. And what is the value of f of 0? It is k. So now k will be equal to limit x tends to 0. Now, if you use LH rule here, this differentiation product rule you have to use. So, x into derivative of e raised to x, which is e raised to x, plus e raised to x into derivative of x, which is 1, plus tan x. Derivative of tan x is sec square x upon derivative of sine 3x. It's cos 3x into 3. Right? And now if you check, the indeterminate form is gone. So that means k equals to, I can substitute x ki jagah pe 0. So here I'll get 0 plus e raised to 0 plus sec square 0 upon cos 0 into 3. So what is e raised to 0? It is 1. What is sec square 0? Again 1. And what is cos 0? 1. So 1 plus 1, 2 upon 3. That means my value of k is 2 upon 3. I hope it is clear now. Now I think audio is okay, right? So let's see if I turn the video, what is the response? Okay. I hope this question is clear. If yes, we can move on to the next question. Okay. Tell me the audio and video are clear or not. Yes, no. And did you understood the question? Okay, fine. Very good, very good. Let's proceed further. So, next question is this. Discuss the continuity of f on its domain. So here f of x is given and it is given while it is breaking on 2. The function is 2. That means where do I have to check? I have to check particularly on 2. But here's the twist. The function is a modulus function, which is already a piecewise defined function. So we have to also break the modulus function. There are two modulus functions, so we'll break both the modulus functions. So let's try it this way. First, where x plus 1 will break, mod of x plus 1 will be equal to x plus 1 if x is greater than or equals to minus 1, and it will be minus of x plus 1 if x is less than minus 1. Correct? Similarly, mod of x minus 5 will be x minus 5 if x is greater than or equals to 5, and will be minus of x minus 5 if x is less than 5. So this way, after breaking the function, my f of x now will look like, please see carefully, x is greater than minus 1, less than minus 1. So for minus 3 to minus 1, this x is less than minus 1. And minus 3, so it is given, it is from minus 3. My f of x will be minus of x plus 1. Then from minus 1 to 2, minus 1 to 2. Here that is less than equals to 2. Minus 1 to 2 means x is greater than minus 1. My function will be x plus 1. Then between 2 to 7, we have to break at 5. So from 2 to 5, x is less than or equals to 5, or you can simply write x is less than 5. From 2 to 5, my function is less than 5 means minus of x minus 5. And lastly, when x is from 5 to, that means x is greater than 5. So my function will be x minus 5. So finally, after using the definition of mod, my function got broken into 4 parts. So where should I check the continuity? Where the function breaks. Here I have to check at minus 1, then 2, and then 5. Means in 3 points, we have to check the continuity. Let's proceed. Now there are 3 points. Now I hope you got the gist of what to do. So I'll be doing something directly. So we'll directly do at x equals to minus 1. LHL. At x equals to minus 1. Left hand limit. Left hand limit means x is less than minus 1. Any of the forms will not be an indeterminate form. Okay. So if it is not an indeterminate form, there is no need to use L'Hopital and all. So LHL will be equal to minus of minus 1 plus 1, which is I guess 0. RHL. RHL means this definition will use, which is minus 1 plus 1, which is equal to 0. We put x equal to minus 1. And lastly, f of minus 1. Where there is equality? Here. So we'll use this definition. Again, minus 1 plus 1, which is equal to 0. Now, all these are equal. That means the function is continuous at x equal to minus 1. Now, similarly, we can check at 2. So, at x equals to 2, just put the value as x equal to 2 in all of them. So, LHL, which definition will I use? Left hand limit means this definition. X plus 1 means 2 plus 1, which is 3. RHL means this definition means minus of x minus 5, which is minus of 2 minus 5. So minus of minus 3, which is again 3. Lastly, the functional value, which is f of 2. Here it is equality. So we'll use f of 2 equals to 2 plus 1, which is again equals to 3. That means LHL equals to RHL equals to functional value. So that means my function is again continuous at x equal to 2. So minus 1 also continuous, 2 also continuous. Right? Minus 1 also continuous, 2 also continuous. Okay. So now we have to check at 5. Now that I am not doing because the function is continuous as 5. You can check it yourself orally here. I'll give you 30 seconds to check at x equal to 5. The function is continuous. That means what will be my final answer? My final answer will be the function f is continuous on its domain. The function f is continuous on its domain, where the domain is from -3 to 7. Got it? I hope it is clear. Now, at x equal to 5, just you calculate mentally and tell me what is the value of LHL, RHL and functional value. It will take just 10 seconds, but still I'll give you 30 seconds. Chalo. You please tell me orally at x equal to 5, what is the value of LHL, RHL and functional value. Okay? Let's do it. Anyone? If you have some pen and book, then also you can try it there. What is LHL, RHL and functional value at x equal to 5? Let's see. Anyone? Or should I do it? I have to do it on the next page. Did you got an answer? Hello? 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 Am I audible? Hello, hello, hello. Yeah, say, what is the answer? You got an answer? Beta? F of 5 equals to 0. Superb, superb. F of 5 is equal to 0. F of 5 equals to 0. Very good. So, very good, very good. Chalo. So, you got an answer. That means the function is continuous. So, that was all for continuity from my side. If you have any doubts and all, you can always ask, and or you can bring it on the next class. LH will be 0, RH will be 0. Super. So all the values are 0. That means the function is continuous at 0. All the points it is continuous. Therefore, it is continuous in its domain. So let's now move on to the next chapter, interesting chapter, which is differentiability. Now, differentiability is the next topic for us. So, let me again revise. You must have been saying this, sir, is repeating every time, but it is very important to know what are we studying calculus for. So, limit was to study behavior of the function in the neighborhood, aju baju of a point. Continuity helps us that if the function is continuous or not, broken or not broken. Now, next is differentiability. What does differentiability helps us? Differentiability basically helps us to know whether there are sharp edges on the function or not. For example, let me see the sine function. This is a sine function. There are no sharp edges here. But suppose say if I take a function like this. So there are many sharp edges. This is a sharp edge. This is a sharp edge. This is a sharp edge. So differentiability helps us to identify whether the function is whether a function has a sharp edge or not. So this is the significance of differentiability. Although it is very minute significance, but it is still pretty good to know whether a function has a sharp edge or not. So let's move forward and see what happened here. Okay. Yeah. So let's move forward and see now. Let's move forward and see that how do we identify the sharp edge mathematically. So let me tell you, if a function has a sharp edge, then at that point, we cannot find its derivative. If a function has a sharp edge, then at that point, we cannot find its derivative. That means we say the function is not differentiable at that point. The function is not differentiable at that point. So, and if a function does not have a sharp edge, that means the function is differentiable at that point. So, this is the algebraic meaning of sharp edge. Now, let us see how do we algebraically define differentiation. Okay. So, a function is said to be differentiable at point x equals to a if this limit exists. If this limit exists. Now, similar that in limit, we always have two, left hand limit and right hand limit. So if we consider the left hand limit and the right hand limit, this function or this limit gives us differentiation. That means I can write dy by dx as limit h tends to 0 a plus h minus f of a upon h. So from here we can say that if this limit exists, meaning derivative exists, and if this limit does not exist, meaning derivative does not exist. Now, what is the condition for limit to exist? This limit can exist if the left hand limit is equal to the right hand limit. But in differentiability, we say left hand derivative, which is LHD. is equals to right hand RHD. The left hand limit, right hand limit, or you can in differentiability we can say left hand derivative and right hand derivative. So similar to limits, for a function to be differentiable, the left hand derivative should be equals to the right hand derivative. So let me tell you one simple thing, that now what is the relation between differentiability and continuity? Okay, got it? From this, again, I would like to repeat, this limit will exist, meaning derivative will exist. Derivative will exist. That means there will be no sharp turns. This limit does not exist, means derivative will not exist. Derivative will not exist, means there will be a sharp turn. And this limit is obviously divided into two parts, the left hand side and the right hand side, which here in this chapter we called left hand derivative and right hand derivative. So basically that means, yes, you have to remember this formula. Limit h tends to 0, f of a plus h minus f of a upon h at point x equals to a. So now let us take an example to understand it more clearly. So as you can see here, we have a function f of x, right? And we have to examine the differentiability at x equal to 2. So very simple thing, very simple question. We just have to find the left hand derivative makes this and the right hand derivative. And if both the values are same, then we say the function is differentiable, right? So let us calculate the left hand and the right hand derivative. Okay. So we know that this is a modulus function. It will break into two parts. So f of x will be equal to x minus 2, so as it is. Minus 2 if x greater than or equal to 2. That means x minus 2 the whole square. And this will be equal to x minus 2 into minus of x minus 2. When it will be possible? When x is less than 2. That is minus of x minus 2 the whole square. So this is the definition of the function we obtained. Now we have to check two things. Left hand derivative, right hand derivative. At x equals to 2. That means that x equals to a. So what is the value of a? It is 2. So if I calculate the left hand derivative, well, how does left hand derivative is given? Limit h tends to 0. Do you remember this one? F of a plus h minus f of a upon h. F of a means 2. I think there is a mistake in this formula. Here it should be minus. Okay, okay. Here it should be minus. But right. So f of 2 minus h minus f of 2 upon minus h. Then there will be minus h. Okay, this is a change in formula. Sorry for that. So this is the left hand derivative. Now, what is f of 2 minus h? F of 2 minus h means the functional value, and f of x is x minus 2 the whole square. So that means I can write it as limit to 0 f of 2 minus h, means x की जगह पे 2 minus h. So 2 minus h minus 2 the whole square. Please understand here, this is 2 minus h and this is x. So just like functions, functions. Like if f of x is 2x, then what will be f of y? It will be 2y. Just substitute in place of x. So that only I am doing. Here in bracket I am writing 8 minus f of 2 means in place of x it is 2, since here is an equality. Therefore, we are using this definition. This is 2 minus 2 the whole square upon minus h. That is equals to this 2 gets cancelled. This is 0. So we'll get limit h tends to 0 minus h ka square upon minus h. So, and we'll be left with limit h tends to 0 minus h. Since it's not an indeterminate form, just substitute a value of h. So minus 0, which is equal to 0. So this is my left hand derivative. So let's move and check right hand derivative. What is right hand derivative? It is limit h tends to 0. A plus h means f of 2 plus h minus f of 2 upon h. Chalo. Let's move forward. So again same f of 2 plus h means x ki jagah pe 2 plus h. So what will I get? I will get limit h tends to 0, 2 plus h minus 2 the whole square minus 2 minus 2 the whole square upon h. Again this will get cancelled. This will be 0. Limit h tends to 0, h square upon h. H and h will get cancelled. So I will get limit h tends to 0 of h, which is equal to 0. Both the values, the left hand derivative and the right hand derivative are same. That means differentiability is correct. That means the function is differentiable at x equals to 2. That means there is no sharp turn at x equal to 2. I hope it is clear. Any doubts here? Please, if it is clear, then give me an answer, yes or no. And you have, if any doubt, you can ask. Clear or not? Yes, no, jaldi. Hello. Yes, okay, super. Chalo. So if this example is clear, means you now know how to use the differentiability formula algebraically. Graphically, it is very simple. Now you also know how to use it algebraically. Just simply calculate two things, left hand derivative, right hand derivative. If they are equal, then function is differentiable, means no sharp turn. If they are not equal, then function is not differentiable, means there is a sharp turn. So now there is a relation between continuity and differentiability. That is, there is a relation where the function is continuous and where a tangent can be drawn or there is no sharp edges. So before that, let me tell you graphically one more thing, that suppose, let's see an example. If I have some graph like this, and at this point I need to draw a tangent. It is very simple. We'll draw a tangent like this. But if my graph has an edge, a sharp turn, then is this a tangent to the graph? I don't think it is a tangent. That means that on a sharp turn, we cannot draw a tangent. We cannot draw a tangent. So this is another way to interpret differentiability. If a function is differentiable at a point, that means we can draw tangent at that point. That also means there is no sharp turn. And if a function is not differentiable at that point, that means we cannot draw a tangent. That means there is a sharp turn. So basically, we have just related the existence of tangent with sharp turns. So how does continuity and differentiability are related? So here it is given, every differentiable function is continuous. That means a differentiable function means at every point on that function, I can draw a tangent. And it is common sense, if a function is breaking at some point, then I cannot draw a tangent at this point because that point does not exist. I hope you are getting it. If the point is not in the domain, then how can I draw a tangent at that point? Point ही नहीं है, point ही नहीं है. So I am not able to draw a tangent. So therefore, this is very important definition. It means a function is differentiable. That means at every point on the function, I can draw a tangent. It is only possible if the function is continuous. We saw the last example. If the function is not continuous, that means we cannot draw a tangent. So from here we have four things. The first one is this. Every differentiable function is continuous. The second one is this. A continuous function need not be differentiable. For example, this. This is a continuous function. There is no breakage at the point. But at this point, there is a sharp turn. And if there is a sharp turn, that means my function is not differentiable. So this function is continuous, but it is not differentiable. That is what this statement is saying. A continuous function need not be differentiable. The third is a discontinuous function is always non-differentiable. We saw this here. I don't think I need to explain it more. But then too, if the function is not continuous, then it is not possible to draw a tangent. And if it is not possible, means the function is not differentiable. So let me sum it up for you in short. Differentiable function implies continuous function. And discontinuous function implies non-differentiable function. These two you need to remember. If the function is differentiable, it is continuous. But if the function is discontinuous, then the function is non-differentiable. Right? So let's look at this example. Here we have been given f of x equals to mod x. And at x equal to 0. So till now we have been checking algebraically. We saw the last example how we used algebra for seeing differentiability, like basically calculate LHD and RHD. So same you can do here. F of x will be equal to x if x is greater than equals to 0, and will be equal to minus x if x is less than 0. You can do the same thing at x equal to a. Just in place of a, we have 0. But starting में I said if you know graphs, if you know to read a graph, that means you are done with most of the problems in calculus, almost 50% of the problem. Why is that? Let me show you. If you know the graph of mod of x, I hope you know the graph of mod of x. It is basically like a V, where this is 0, right? It is like a V. So at x equal to 0, if we know the graph, we can like this. Directly in a second, see that there is a sharp edge, sharp turning at x equal to 0. And sharp turning means the function is non-differentiable at x equal to 0. But as you can see, there is no breakage in the function. That means the function is continuous at x equal to 0. So what can I say here? From directly looking at the graph, see, don't need to calculate so much LHD and RHD. If you know the graph of these function also, this is also very simple functions. You know the graph, like you should know the graph of these functions. Then we can directly tell how to, like, what is the nature of the function. So here it is continuous at x equals to 0, but since sharp edge, it is non-differentiable at x equals to 0. So this is my final answer. I hope you are getting it. If you know the graph, you can also calculate algebraically by using LHD and RHD. That I am. But this was our main aim, if to show whether if you are familiar with the graphs. Mod X is a very popular graph. I hope you all know the graph of mod X. Okay. Now, let's see further. So this is a question. It is saying, show that the function is continuous but not differentiable. So, and it is given at x equal to 3. So let me just write what do we mean by continuous. Continuous means left hand limit is equals to right hand limit is equals to the functional value at 3. Differentiability means left hand derivative should be equal to right hand derivative. So here it is given non-differentiable. That means the left hand derivative and the right hand derivative will not be same. Right? Okay. Let's see. So, interesting thing, if you know the graph of these functions, this is a straight line, this is a parabola. I hope you have heard of what is a parabola. So if you know the graph of straight line and parabola, you can directly plot the graph and you can directly see on the graph. But let's assume we don't know the graph. Then also we have one algebraic method. What is the algebraic method? That we calculate the left continuity. Let's check for continuity. Left hand limit means limit x tends to 3 minus. 3 minus के लिए this is a definition 2x plus 1. So that is no indeterminate form. 2 into 3 plus 1, which is 7. Let's check right hand limit. Right hand limit means limit x tends to 3 plus. 3 plus के लिए definition 16 minus x square, which is 16 minus 3 square, which is 16 minus 9, which is 7. Let's take the functional value at 3. Functional value at 3 means this definition again. Equality is there. So 2 into 3 plus 1. 3 to the 6 plus 1, 7. So left limit is equals to the functional value. That means f is continuous at x equals to 3. Now, let's check the differentiability. So, LHD. LHD, if you remember, limit at x equal to 3 means at x equals to a. So, a ka value is 3. F of a minus h minus f of a upon minus. So equality is here. So for 3 minus h, we'll use this. So limit h tends to 0, 2 into 3 minus h plus 1 minus f of 3. We directly know f of 3, so I am writing it from here. It is 7. So minus 7 upon minus h. What we'll get? We'll get limit h tends to 0, 3 2s are 6, minus 2h plus 1 minus 7 upon minus h. 6 plus 1, 7 minus 7. And here we can also cancel limit h tends to 0, minus 2h upon minus h. So minus minus h got cancelled and we got the answer as 2. We got the answer as 2. Okay. That means LHD is equal to 2. Let us calculate RHD. So what is RHD? RHD is limit h tends to 0, f of 3 plus h minus f of 3 upon h. So f of 3 plus h, three plus h. 3 plus h means x is greater than 3. And if x is greater than 3, we have to use this definition. H is getting added in 3. That means 3 plus h is greater than 3. Simple. Here it was less than 3 because h is getting subtracted from 3. That means x. So it will be limit h tends to 0. This definition 16 minus 3 plus h the whole square. I am again directly writing it as 7 upon h. So this will be limit h tends to 0. Open this bracket. 16 minus a square plus 2ab plus b square minus 7 upon h. So I'll be getting 16 minus 9 is 7 and 7 minus 7 gone. I'll get limit h tends to 0. From this both I can take h common. I will get 6 plus h upon h. H and h got cancelled. and h की जगह पे we substitute 0. So I will get 6 plus 0, which is equal to 6. As you can see, these both LG and RG are not equal. So what do we conclude? F is not differentiable at x equals to. You remember LHD, RHD? But we have to simply calculate value. As you have seen, there is no such tough questions on indeterminate forms. The indeterminate form are very simple. Sometimes we directly get to, sometimes we just have to cancel a factor. There are no 1 raised to infinity, infinity raised to 0, 0 raised to 0, such indeterminate forms. So the limit calculation is very simple. You just need to substitute the function in place of what? Right? So this is the last example. And again, if you remember, in today's class only we did this. Now we have done 3 times. Once in limits, once in continuity, and once here. I am not again doing continuity because just at the start we did this question. And if you remember, LHL equal to RHL equal to f of 0 all came equal to 0. I hope you remember it. So that means it is continuous at x equals to 0. Now, let's check for differentiability. So for differentiability, same two things, LHD and RHD. Now, let me tell you, okay, let's check LHD. LHD means limit h tends to 0, f of 0 minus x. At x equal to 0 means at x equal to a. So a is 0 minus f of 0 upon minus h. So I will get limit h tends to 0, f of 0 minus h. There is no left side and right side. So we'll simply use this definition for both. I will get f of 0 minus h means f of minus h, right? Minus h ka square cos of 1 upon minus h minus f of 0 is 0 upon minus h. So here I'll get limit h tends to 0, 1h will get cancelled. I hope you are getting it. Okay, let's not cancel it, we'll cancel it after. Achha, cos of minus theta is cos theta. Minus doesn't make a difference in cos upon minus h. 1h will get cancelled. And again, this is not an indeterminate form. This is 0 into a value between minus 1 and 1. That is basically 0. So LHD is 0. What is RHD? RHD equals to limit h tends to 0, f of 0 plus h minus f of 0 upon h. Means f of h. 0 में अभी क्या 0 plus h is h. So will you left side and right side? So we limit h tends to 0, h square into cos of 1 by h minus f of 0 is 0 upon h. So here again, one power will get cancelled and I will be left with limit h tends to 0, h into cos of 1 upon h. Again, this is not an indeterminate form. This is 0 into a value between minus 1 to 1, which is equal to 0. Superb. So LHD equals to RHD. That means the function is continuous as well as differentiable at x equal to 0. I hope it is very clear. So function is continuous differentiable. It is very simple. Algebraically, so very, very simple. You just have to remember two things. Continuity. Will I say function is continuous algebraically? Left hand limit equal to right hand limit equal to functional value. How will I say function is differentiable? Left hand derivative equals to right hand derivative. Simple two things. Graphically. How will I say function is continuous graphically? There is no breaking. How will I say function is differentiable? There is no, I'm waiting because I thought I like you all to read. There is no sharp edge. But so graphically we studied continuity differentiability. Mathematically we also studied both. So next time we'll be finding the formulae. Like, you know, what is the derivative of sine x? It is cos x. So how that formula came? Y is derivative of sine x is equals to cos x. That all will be deriving next time by using the same first principle. We did what we did on the first page. This formula. dy by dx equal to this. We'll be using this to get the derivative of our standard function. Sine x ka cos x square ka derivative 2x and so on. So that time will next lecture means I guess Thursday it is. So Thursday we'll be seeing that. Okay. I hope it is all clear now. So let us end today's session. I hope it was very good for you as it was good for me. See you the day after tomorrow on Thursday. Chalo. Bye bye everyone. Take care. Thank you all. Bye bye.